Okay, this is going to be a video lesson on Algebra 1 graph characteristics. Okay, where we do the transformations, the first part of the unit. Now we're going to put all the functions together. Okay, some of these terms we've already talked about probably this year. Okay, x-intercept is where the graph crosses or touches the x-axis. The y-intercept is where the graph crosses or touches the y-axis. Now, earlier this year we talked about with domain and range. The domain was the x values and the range was the y values. Now, with a graph, unlike points, we're going to do domain is smallest x to biggest x, range is smallest y to biggest y. Now, in order to find the domain and range, you have to label the following things. Arrows, which we'll get into in a second, endpoints, minimums or maximums, which in our case are like the vertexes of our quadratic, okay? And the asymptotes, like in our exponential function, okay? Now, let's talk about labeling an arrow. Okay? So, let's go ahead and draw these for pictures. All right, now, when you label an arrow, okay, an arrow we're going to label like a coordinate point. If that arrow is to the left, I put negative infinity. If that arrow is to the right, I put positive infinity. If the arrow is pointing up, I put positive infinity. If the arrow is pointing down, I put negative infinity, okay? Now, the only time you're not going to do that is if your arrow approaches an asymptote, okay? These are not asymptote ones, okay? Now, how you figure out whether the left arrow is a right arrow, just hold up your hands. Whichever arrow is furthest to the L, the actual L, that's the left arrow. So that's negative infinity, and this one would be positive infinity. What is this arrow doing? It is going up. What is this arrow doing? It is going down. So that is how I label that one. Okay? So which one's the left arrow? Well, it's got to be this one. So left arrow, right arrow. What's this arrow doing? Going up. What's this arrow doing? It is also going up. Okay? In class, you will do these on your own. Okay? All right. Left, right. This arrow is going down. This arrow is going down. Okay? Left, right. This arrow is going down. This arrow is going up. Okay? All right? Now, okay, we're going to do something called interval notation. Okay? All right? Okay? Give you a real simple example, okay, before we get to the other ones. All right? Let's say this point we're negative 3, 5. I would want to label that. Okay, let's label my arrows. I have negative infinity. I have positive infinity. Okay? This arrow is going up. This arrow is going up. Okay? So when I go to find the domain, all right, domain is smallest x to biggest x. So here are my x values. Now, sometimes people get confused with the infinities. If you need to think of it this way, negative infinity is like negative 100, and positive infinity is like positive 100. Okay? So, given the choices, negative infinity, negative 3, or infinity. Now, think of it this way. If it was negative 100, negative 3, and positive 100, which one would be the smallest? That would be this number, so it's negative infinity. Now, when you're using infinities, you use curved brackets, okay? What is the biggest in this case? That would be 100 or infinity. Okay, now what does that mean? That means all real numbers, okay? When you got negative infinity to infinity, that's what that means. Now, for the range, those are the y values. Now, here are my y values. I've got infinity, I've got 5, and I've got infinity again. Once again, if this helps you, 100, 5, 100. Which one of those numbers is the smallest? That would be 5. Now, we use these square brackets for all points that don't come from asymptotes. So that would be a 5. What's the biggest one in this case? It is infinity. And I would use a curved bracket. So that is the interval notation. Okay? All right, now, let's put this all together on a graph. Okay, find the x-intercept. Where does it cross the x-axis? This is the x-axis, so that would be at 8. So I write x equals 8. This crosses right here for the y-intercept at -2. So that's going to be y equals -2. Now, when I label this, I do not need to label the intercepts. I can label the arrows. Okay, so that is a left arrow. That is a right arrow. This arrow is going down. This arrow is going up. Okay? So my domain, these are the x's. I only have two things to choose from. Smallest x would be -infinity. Biggest one would be positive. So that means it's all real numbers. Now for the y's, for the range, smallest y is -infinity. Biggest is positive. So that is also all real numbers. Okay? All right? Now my x-intercept here, that's going to be at 4. I've got a y-intercept at 8. Okay? To find the domain, this is a left arrow going up. This is a right arrow going down. So I don't need to label the intercepts, just the arrows and the vertices and the asymptotes. Here's my x values. Smallest x value is -infinity. Biggest is positive. Okay, now I'm going to go to the y's for the range. Smallest y is -infinity. The biggest y is positive. Okay? All right, so line, as you can see, is going to be all real numbers for the domain and range. Okay, my x-intercept here. X-intercept is going to be right there at 2. Y-intercept will be right there at -5. Let's label the arrows for the domain and range. That is a left arrow. That is a right arrow. That arrow is going down. That arrow is going up. So my domain. -infinity or infinity, which one's smaller? Negative. Which one's bigger? Positive. Okay? My range, y, y. Smallest y value is -infinity, biggest is positive. Okay? All right, there's some for lines for you to try. Okay, now, we talked about this with quadratics. Okay? All right, we are going to find the vertex. Okay? All right, because that is key for us to doing the domain and range. So that is, I start in the center, that's left 1, then down 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's label our arrows. Left arrow, right arrow, going up, going up. Okay? X-intercepts. Now, X crosses in 2 places. Crosses at 1, crosses at -3. The y-intercept crosses right there at -6. You do not need to label those. So the vertex we already found, -1, -8. Okay? So my domain, my smallest x value, -infinity are the choices, -1, infinity would be -infinity. The biggest of all those is infinity. The range, this is the y value, y value, y value. So I got infinity, I've got -8, and I've got infinity. Which one is the smallest? That is -8. And I would put a squared bracket for that. And then that's infinity. Now, what does this mean? Y is greater than or equal to -8, because the graph goes up. Okay? All right, let's go ahead and label this one. All right, my x-intercept is 5. X-intercept is 1. Okay? All right, y-intercept is at -5. Vertex, 1, 2, 3. 3 over, 4 up. Let's label the arrows. -infinity, positive, both going down. Okay, so my vertex is 3, 4. My domain, I'm doing x values. Smallest x is -infinity, biggest x is positive infinity. That's all real numbers. My smallest y's, I got -infinity, I got 4, I got negative infinity. So that's negative infinity, your biggest would be 4, so that's a square bracket. So that's going to be y is less than 4 because the graph goes down, okay? You can see either example, okay? Now, in this case, my x-intercept is 0, my x-intercept is negative 4. Now, my y-intercept is also 0, so when it's at the origin, if it crosses there, you have both, okay? I've got negative 2 over 4 up for my vertex. Okay, label your arrows. Left arrow, right arrow. Going down, also going down. My smallest x value for the domain is negative infinity. My biggest is positive infinity. Range, my smallest y value is negative infinity. My biggest y value is 4. Once again, this would be y is less than or equal to 4 because the graph is going down. Okay, let's do one more together. Okay, all right. The x-intercept is negative 1. The x-intercept is negative 3. The y-intercept is already up there at 12. Okay, my vertex is negative 2 over negative 4 down. Okay. All right, so negative 2, negative 4. So I got negative infinity, because that's a left arrow. That's a right arrow. This is going up. This is going up. Okay, so for my domain, that's my x's. What's the smallest x value there? Negative infinity. The biggest one is positive infinity. My range, my I got infinity, got negative 4, and I got infinity. Okay. My smallest one is going to be negative 4. My biggest is going to be positive infinity. Okay? All right, so go ahead and pause your video. Go ahead and try those on your own. Okay, now, we're going to get into exponential characteristics. Now, there is no vertex, but I have to label the horizontal asymptote. Okay? And the idea here is that's going to be y equals negative 4. So it's leveling off at 4. That's going to be important in a second. Okay? Now, I got an x-intercept of regular 4. I've got a y-intercept, I'm going to say, of negative 3.9. It's not quite at 4, negative 4, but it's close. All right, now, what if I said negative 3.8? It's okay, as long as it's reasonable. Okay, my asymptote there is y equals negative 4. Okay? Now, when I label the arrows, this is the only port that is different. Okay, the x's are still the same. That is a left arrow, that is a right arrow. This arrow, okay, so you can write this down. The arrow closest to the asymptote gets that number for y. What I mean is, this is leveling at negative 4, so I am going to put negative 4 right there. Now, this arrow, just like before, that is going up. Now, this is my x, this is my x. Smallest is negative infinity, biggest is positive. So that's still all real numbers. My range. My y, I only have two y's, negative 4 and infinity. Which one is bigger? That's negative 4. Now, since it comes from the asymptote, I put a curved bracket, okay? So this is because it's from an asymptote. I got that number. I didn't get it from a dot. I got it from an asymptote. My biggest would be infinity. What does this mean? This is y is greater than negative 4 because the graph goes above the asymptote. Okay? All right, so let's find this. Now, as you notice, does this cross the x-axis? No, so that's none. Crosses the y-axis at 7. Okay? Let's label this. Okay, where is that line? That line's at 4. Okay, so that's my asymptote there. All right? Now, let's label my arrows. Okay, that's a left arrow, that's a right arrow. This arrow is going up. This asymptote is this arrow is approaching 4. So I got x, smallest x is negative infinity, biggest x is positive infinity. Smallest y value, I've I've got a y value of 4, and since it comes from an asymptote, it's curve bracket. The other one is going to be a curve bracket because it's infinity. Okay? Now, I've got an x-intercept, I'm going to say of 1.9. It's not quite a 2. If you put 2, that's not wrong. The y-intercept is at 5. Okay? All right, now, I want to figure out where this asymptote is. This is leveling off at y equals 7. Okay? So y equals 7 is that. All right? Left arrow, right arrow. This arrow is going down now. Okay? Now, this arrow is getting close to 7, so that's what I would have. So this is my x. Smallest x is negative infinity, biggest is a positive. It's all real numbers. That's y and y. So I got 7 and negative infinity. Now in this case, negative infinity is the smaller one. The bigger one is 7, once again, because it comes from an asymptote. This would be y is less than 7 because the graph goes below. Okay? So the curve refers to that inequality underneath. Okay? All right? So that crosses, let's say at negative 6.5. That's a good estimate. That's like y equals 3. We'll go ahead and say that. Or negative 3. We can go ahead and say that. All right? So I'm going to go ahead and do this. Okay, so that asymptote's at y equals negative 3. Okay. This is a left arrow going up. This is a right arrow leveling at negative 3. So my smallest x value is negative infinity, biggest is positive. Now my choices are infinity or negative 3. Which one is smaller? Negative 3, since it comes from an asymptote curve bracket. This is infinity. And that means the graph goes above, okay, the asymptote. Okay, so go ahead. I think that's it. I don't think there's a 19. All right, that's it for the characteristics. Go ahead and practice those and go formative.